Alright, tech enthusiasts, get ready to have your minds absolutely blown. For years, the holy grail of mobile computing has been true. Powerful artificial intelligence running locally on your device. We've seen small steps, impressive for their scale, but nothing like what we're about to discuss today. This isn't just big news. It's a seismic shift, and it's been the absolute top story dominating hacker news, a project called Bonsai 27B. Imagine this, a 27 billion parameter AI model, running on your phone. Yes, your smartphone, the device you're probably holding right now, or watching this video on. A model of that size, previously, was the domain of server farms, supercomputers, and cloud infrastructure, consuming colossal amounts of power and memory. But Bonsai 27B is here to shatter those preconceptions. It's a 27B class model, designed to fit and run efficiently on a mobile device. This isn't a stripped-down, tiny AI. It's a full-fledged, powerful large language model, LLM, ecosystem, reimagined for the edge. So, what exactly is a 27B class model? The B stands for billion, referring to the number of parameters or weights in the neural network. Think of parameters as the knowledge, the complexity, the sheer learning capacity of an AI. More parameters generally mean a more capable, more nuanced, and more intelligent model. For context, many of the impressive generative AI models we've marveled at over the past year or two have been in the tens or hundreds of billions of parameters, often requiring specialized hardware costing hundreds of thousands of dollars to run inference. A 27B model on a phone? That's like fitting a supercar engine into a scooter and expecting it to run just as fast, if not faster. The immediate question, of course, is how? How is this even remotely possible? It boils down to a brilliant convergence of advanced techniques in model compression, hardware optimization, and software wizardry. Let's break it down. First, there's quantization. This is perhaps the most critical technique. Most AI models are trained using 16-bit or even 32-bit floating point numbers to represent their parameters. Quantization reduces these high-precision numbers to much lower precision, like 4-bit, 2-bit, or even 1-bit integers, with minimal loss in accuracy. Imagine taking a very detailed photograph and reducing its file size dramatically by using fewer colors, but still keeping it recognizable and useful. This dramatically shrinks the model's footprint in memory and on disk, and makes computations much faster as the NPU can handle simpler operations more efficiently. Bonsai 27B likely employs cutting-edge quantization strategies to squeeze those 27 billion parameters into the limited memory of a smartphone. Second, we have the incredible advancements in mobile hardware. Modern smartphones are not just communication devices anymore. They are sophisticated computing platforms, especially when it comes to AI. Leading chip manufacturers like Apple, Qualcomm, and MediaTek have been investing heavily in dedicated neural processing units, NPUs, or AI engines. These specialized silicon components are designed from the ground up to accelerate AI workloads, performing parallel matrix multiplications and other common neural network operations at astounding speeds and with incredible power efficiency. Without these NPUs, running such a complex model would drain your battery in minutes or simply be too slow to be practical. Bonsai 27B leverages these hardware accelerators to their fullest extent, offloading complex AI computations from the general-purpose CPU or GPU. Third, software optimizations play a massive role. This includes everything from highly optimized inference engines to efficient memory management techniques. Frameworks like Apple's Core ML, Google's TensorFlow Lite, or custom, Highly optimized low-level libraries are crucial. These frameworks are designed to minimize latency, optimize data movement, and ensure that the quantized model runs as smoothly as possible, taking full advantage of the underlying hardware architecture. It's a symphony of hardware and software, meticulously tuned to perform an incredible feat. So, why does this matter? Why is Bonsai 27B such a game changer? The implications are truly profound, touching almost every aspect of how we interact with technology and even raising questions about data privacy and accessibility. Privacy. This is a huge one. When an AI model runs locally on your device, your data, your prompts, your conversations, your personal information never leaves your phone. It doesn't get sent to a cloud server to be processed, analyzed, and potentially stored. This on-device processing fundamentally enhances privacy and data security, giving users much greater control over their personal information. In an era where data breaches and privacy concerns are constantly in the headlines, this is a monumental step forward. Offline capabilities. No internet? No problem. Imagine having a powerful AI assistant available anytime, anywhere, regardless of network connectivity. Whether you're on a plane, deep in a subway, or in a remote location, your phone's AI will still function at its full capacity. This opens up a world of possibilities for travel, education, emergency services, and simply for those moments when you don't have a stable internet connection. Speed and latency. Bypassing the cloud means eliminating network latency. The AI's response time becomes almost instantaneous, limited only by your phone's processing power. This dramatically improves user experience, making interactions feel more natural and fluid. Whether you're generating text, summarizing documents,